what is up. Over here in the corner of the garage, just buried by everything, has been this tall outdoor unit that I was working on like a year ago and I never finished. I actually had some controls in there I made, piddling around, and it worked. Kind of still have some stuff laying in here for test mode. Have a regular scroll in there, which I've unplugged for testing. And I did need to fix the one fan I accidentally blew up, but I have another one. But anyway, I have a new control board for it. Let me grab that real quick. To replace all of that, which the other one I kind of pieced together. I mean, this worked. A lot of discrete components. But to replace all that, or all that, I have this, which I made. And actually, this is not one I made on my own machine, but I laid it out, had it made, and then just had to solder on a couple remaining components. I did forget to put these filter capacitors on my optical isolators to filter the 24 volt AC conversion to logical inputs, but that was a quick, easy fix. But this has worked in testing. Got all my thermistor inputs right there. It's got the defrost sensor, which is just on the coil, another coil sensor, and an outdoor air sensor, and a couple relays to stage the variable frequency drive for Y1 to Y2 and stuff like that. But I don't know, I kind of just stalled. That was a long time ago I made that now, a while back. So it's just been sitting here. One other thing, reason I didn't put it in, is I was in haste. I kind of, when I repurposed this coil, I kind of installed a metering device, which is an electronic metering device on each half of the coil. These are actually 2 coils, so it's a 3-ton unit, so it's like 1.5 ton, 1.5. It's actually quite a bit for the capacity. So this one's down here, which already was kind of there. I just repurposed it and I added the other one up here. I did add like check valves. There's a check valve right there, and there's a check valve down here somewhere. It is. What are you? Oh, it's right here. Man, I really put it right there. So the way these were is, so in cooling mode, it'd come out and just go straight to the liquid line, which I just have split here. But in the other mode, let's see, where's the check at? Over there? Yeah, right here. Here's the line. It would basically hit the check and then have to go through the metering device. And I was going to have to install coil temperature sensors on both coils to independently run the expansion valve. And I got thinking, this is just a heat pump. We're primary cooling in this climate. Heating doesn't need to be perfect. So I think I'm going to redo it. I think I'm going to take these out, which I'll just have to cut or unbraze there and here. And I'm just going to put capillary tube, which I seem to be enjoying again. So capillary tube. And kind of using a calculator, you can just put your BTUs and some coil temperatures. You get pretty close. Okay, let's show you what I'm making. Each one of these is sized for 9,000 BTUs. So it's 9,000 and 9,000 to be 18,000, and then 9,000 and 9,000 to be 18,000. So this is out of a roll that I cut to size. I think I got like 32 inches at that size. And then, so basically I just pluck these out. Here's one of them, my metering devices, electronic expansion valves. And I just took this bottom one out, so I'm getting ready to braze in that one. But I'm just going to show you, here's this one that's put in place already. So I just unsweated it, kind of swaged it a little bit, ovaled it. It's all clean, already blew it out with nitro and everything. And then I'm got to roll this capillary tube into the round. So all you do is just find something like a lithium-ion battery, for example, to roll that around. I just made the bottom one. Actually got a phone call, so I didn't film any of it. But there she is. It's under pressure test now. Every time I come out here to record a clip, the damn Goodman unit's running. Anyway, this is one of the fan motors out of the dual fan, tall mini VRF unit. I actually just took this magnet armature section with the bearings out of this one, which is the one that burned up out of the dual fan unit, and switched it into the one that was out of this. Wattage rating's a little different, but it's the same. Everything else is the same otherwise. Put the phone down because the magnets are strong, but this is what it is. It's a synchronous DC motor, and there's the bearings. There's those. You could change these bearings if you wanted to. Look, the numbers are right there. But what's wrong with this is it's shorted out from me. I was screwing around with the motor, hooking it right up to a VFD just to run it instead of the compressor. And synchronous DC motor will kind of rotate and run off of a standard VFD, but it will kill the motor, and it did. It killed it. I left it on too long. I was just screwing around with the unit, testing controls in the unit, so I just wanted something hooked up to the VFD and not the compressor, so I hooked this up. Unit just went in the defrost. There's not a lick of ice on the coil. Anyway, putting this back down in there, see how stiff this is? It's because the windings are shorted and you're turning magnetic fields. You're cutting magnetic fields through the windings, which makes the windings act as a generator. And the windings are shorted. Okay, I just plugged this thing all in. 24 volts from transformer to thermostat connections, and this all booted up. And then I hooked up the high voltage, which is just powering the VFD. Compressor is unplugged, so it can't run. And I'm trying to calibrate the fans. And at first, with the pulse width modulation I had it going to, fans weren't even started. But in my program, I have it so I can adjust the maximum pulse width modulation. And I adjusted up a little bit, and the fans actually started. So that's great. So right now, I've 230 volts going in here, rectified, powering this IPM with my own onboard voltage rectifier, and which is going DC out right here, so it's about 330 volts going in there. And then these two wires is 15 volts that comes from here going in, and then the voltage dividers and all that, and got the optical isolator, and then the signal back out, and it's running. It's actually, so I'm going to try to go into my program and speed up the max. So we're going to go in there. I'm going to go to frequency maximum for the fans and crank that sucker up. Oop, wrong way. So using 8-bit values, 255 is the max. I don't think I'm going to have to go that high. So we're going to get up to about 190, and I'm going to save out of it into the EEPROM. So it should speed up a little bit more. Not very noticeable, but I think it did. So anyway, I'm going to play with that for a few minutes. I have to make the video long. It's been a while since I've been in the program for this. I hope I'm in the right one. Got it connected to my spare board here, but I tried to adjust my fan speed up, and it got up there almost to where I need it, but not quite enough. And I see that in here, in my subroutine, my function, it only lets me adjust it up to 240. That's a simple if I'm pushing the button and the Fmax, value is below 240, I can keep increasing it up. So it kind of hard limits at 240. So I'm going to change that to like 255, which is my full value, and then try to ride it into that unit out there and see if it'll let me adjust it higher. Okay, I just changed that to 255. I just loaded my pick kit. I've never used the programmer to go function, but supposedly now I'll go power that up and plug that into my chip out there. I should be able to just hit the button. It's got the EEPROM in here, or the hex file I should say, and it's going to dump it into my device. And we'll see if it works. I always get a little nervous when I come on ways and I start hooking wires up and I don't want to fry nothing. So I think this is ready. It says push it. Ooh, it's got the red light going. I don't see anything happening on my LCD there, but Oh, there we go. It just blinked that, so it usually means it's interrupted it. Now it's running again. So, okay, cool. Should be able to unplug this. And let's see if it'll let me adjust it up that high. Okay, back in the menu adjustments. And before it would hard stop at 240, so let's see if it goes up to 255 now. Oh, it did. All right. It's the first time I've actually programmed this, the charge programmer to go function. There, it's stopping at 255. I'm going to go ahead and drop it down to 250. Yeah, there. Save to EEPROM. This first button's kind of messed up on here. I'll plug my little header that I used to program it. Now I need to hook up my high voltage and see if the fans go a little faster. Okay, I'm going to jumper Y to red, which is heat. Okay, which puts the fan to fast, which now I set it for 250. Both fans are starting. By the way, this is the fan motor I took apart. Put this shaft and magnet section into the fan housing of the small one that just has a single. That is faster. That's probably almost as fast as it needs to go. I mean, it's 2 fans for a 3-ton system. So it's probably as fast as it needs to go. I had a bunch of overkill programmed into this thing to like adjust. When it's in cooling, it adjusts based on liquid line temperature. So let me go ahead and crank this sucker up a little bit though. Ah, shit. Keep editing. Button 3. Okay. When you program something almost a year ago, you kind of forget, you know. Alright, there we go. We're going to save. Yeah, I might need to stop and restart for it to go to that max, because in the code it just says go to max. Well, max is what I have stored in that EEPROM value. Obviously it already took it, so got delay on brake going. I'm pretty sure I put like pushing buttons or something to bypass it or skip it down. There we go, to jump it down to 5 seconds for when I'm doing testing like this. I like to put stuff in there. All right, fan speed 255. See if that goes any faster than that was. And some of this is a little bit of a guess because it's a voltage divider and all that kind of stuff in there, with it, working with an optical isolator in here and whatnot. And I know it doesn't need a full 15 volts to operate the input, but 15 volts is what this sends out for the power. So divide it down and then using the pulse modulation, 255 should pretty much just be maxed. Okay, and this is a spare board, by the way. Looks like that's another spare board. When I ordered them to be made for me, they came in 5 packs. And here's an interesting thing, is this resistor right here, and I could have sworn I let them put all the surface mount stuff on. They put all this on for me. I only added the switches and the optical isolators and the pins, I think, that they didn't have. And I mean, these relays, these connectors, all this rectifier, all this stuff they put on. So in fact, let me compare it to a board that isn't addressed. Yeah, this is how it came, like this, because there's one I haven't added the ISOs, the buttons. Actually, these pins were on there. So I accidentally used too small of a header pin, by the way, for programming it, which why to make that ridiculous adapter. But anyway, so yes, they put these resistors on there, and they made a mistake. They made a mistake. So 10K, 10K. Looking in my design, this section right here, this is it. This is my HP control that I designed. And there's a 10K from the 15 volt signal coming from that IPM module, goes to feed the top of that transistor output, optical one. And then the pull down resistor right here to ground is 33K ohms. And when we go over to the layout, and you'll see that this layout is this board. This is this. this resistor, our fan, and when I click on it to identify what it is a 10K, where did it show? I gotta click on, oops, I clicked on one pad, hold on. There we go. 33K ohm. So I don't know what happened in that, but somehow my boards came with 10K there, which is really pulling down the voltage, and which is why it's not getting enough. So I got to go change that to a 33K, and that fan's going to haul ass. That actually wasn't so bad. So I removed that from the 10K, 10 times 3, put a 33 times 3, 33K for the pull down. That should be correct. Now let's put power to it. And as always, hope we don't get any sparks. This is how I'm doing it, by the way. Just plug it in power through a cord. Now let's plug this in. Let's turn it on. That fan should freaking go like a rape date now, because since I programmed it, I just activated freaking short cycle. So I touched that twice. EEPROM still going to load 255, so this fan should haul major ass right now. When they get started, you can see they do the rocking thing that these type of ECMs like to do. What does that show? Does that show it's running? Yeah, it's already going faster. It's going to be going too fast. But that's good. Pulls a lot of amps when these things crank up, because normally these things never run the fans that fast. So now I'll have to do is program this slower, I'm sure likes to focus on everything else except for what I'm doing. And I think I had this programmed before for about what worked out great. That was when the resistor values were correct in the voltage dividers. There goes 210. It's pretty awesome to see this thing running. Something I created just out of my mind. And you always cross your fingers and hope something's not screwed up. There was something screwed up on this board, except for it was because of them, somehow in no order. Unless I find something later where I allowed a substitute. Oops. And that could be, because sometimes it says, hey, we don't have this. But there's no way it didn't have a 33K resistor, I think what I have, like 190 or 170 or something like that was where I had this set before. That button is buggy. That's probably more like it. That'll be a good starting point. And then I could fine tune it when it's actually up and running. So basically, I should be almost ready to hook up. Now this thermistor must not be a 10K, because it's saying like 10 degrees. I'll plug in a 250. That's what I get when it's invalid. And it's probably about 58 degrees out here. So let me plug the defrost in over on this one and see if I get a good value over a liquid. Yep, 56. So my board's good. Thermistors. I just gotta get another 10K thermistor for the coil. I don't remember what I'm doing in the program with that one. Might be something I put in there that I'm not utilizing. I definitely need the defrost one, which is that one. Oh yeah, I need the liquid one. I need the liquid one to ramp the fan and cooling. That's what I was doing. So this is not a 10K. We'll check it and see what it is. So it warmed up the thermistor, and then it started increasing the fan speed. Like I said, if it gets a little warmer above a certain point, I can't remember, it was like 100, maybe it was 110 or something like that, it just immediately goes to max fan speed. But I mean, just getting above the cut-in range or whatever I set, it just starts ramping up until it gets it into the controlled area, and then it just stays there. If it starts cooling off too much, it'll start slowing down, which it's already doing now. So it's probably trying to keep the liquid line somewhere between like 85 and 95. I can't remember. Maybe it's 85 and 90. So you can see already, it's already backing off on the fan. But this here is a thermistor I had my other creation. Now the fan's coming to a stop. So that now will live right here. Might just put a little bit of insulation around it.